let's dive in here. So we're going to talk nutrition and energy flow. The quiz is up on It's Learning. So if you open up It's Learning, you should find that quiz. It's called Nutrition and Energy Flow lecture quiz. And yeah, let's take a look here. This is a cow. Does anybody know what cows eat? Yeah. Yep. They eat what the farmers feeding them hay, things like that. So they're eating plants, right? So that makes a cow an herbivore because it eats plants. So we're going to go through some of this stuff. You guys have used some of these words already when we were outside in particular. Let's dive in. What these words that we've talked about mean, they refer to something called trophic structure. Okay? And trophic basically means feeding relationships. So all the interactions in a community of organisms depend on who's feeding on who between all the various populations. Okay, and that makes up what we call the trophic structure of a community. So it sounds like a big word, but trophic just refers to feeding relationships. So if you're jotting down some notes, you might want to remember what trophic means. Is it too dark if I do that? Yeah, I think it's better. Easier to see. Okay, don't try to write down every last word. Okay, there's no point in that. Some of the stuff you guys are going to know, and you'll be like, I don't even really need to write that down because I just know it. It's simple. Okay. You got it? Let me know if I'm going too fast. We'll start in here at the top with autotrophs. So autotrophs, as you know, are plants. But what I want you to be able to do is put together the two words autotroph and producer. So auto, think of like automatic, trophic feeder. So these things automatically feed. And what is their source of food, their energy? The sun, right? So these things are automatic feeders. They produce materials for the entire rest of the ecosystem. That's what we call them, producers. And there, of course, is a picture of a deciduous forest, which is the biome that we're in that we did the other day. They make their own food, mostly through photosynthesis. There are some that don't do photosynthesis, but yet still make their own energy through chemical means. We call them chemosynthesists. Okay, but most of the ones we'll talk about will just be green things that do photosynthesis. So if you're following along on your quiz there, what you'll see from the first question, you have a whole bunch of choices over there, and it's matching. And of course, you'll see autotrophs up there, and you could probably figure out where to put autotrophs. So you can kind of fill that out as we go if you like. You don't have to wait till afterwards, or you can wait if you like. But it won't work on a phone, so don't try to use your phone. All right, let's do heterotrophs. So heterotrophs, the other word for a heterotroph is a consumer. And their stick is that they eat autotrophs or other heterotrophs or both. So a heterotroph, hetero just means other. So these are other feeders. They're eating other things. They can't make their own energy. That's their feeding relationship. And the word for that is consumer. So you guys are a consumer. You're a heterotroph. Which one do you guys fall into? Both. You eat both. Or you should anyway, right? You should eat your veggies. Some of us maybe only eat meat. That's probably not too healthy. You got that one? So you'll see that on there too on your quiz. Okay. So we call these things that eat autotrophs only autotrophs. We call them herbivores because an autotroph is a plant, right? And plants are sometimes referred to as herbs and spices, right? So herbivores eat herbs, and they're autotrophs. What do we call the heterotrophs? I heard somebody say it. Eat other heterotrophs? Those would be, of course, carnivores, right? Think of carnage. They eat meat. And then, of course, the ones that eat both are called omnivores, which is what we are. Eat both. So we have herbivores, carnivores, and omnivores. Those all fall underneath the consumer or heterotroph heading there. That's their relationship. Next up, we have a group of creatures that feed a little bit differently. They're known as decomposers. And these things absorb nutrients from dead organisms. So they're responsible for decomposing things that are rotting on the forest floor. And the best example of that is a fungus. So any fungus, any mushroom is a great example of that. Bacteria do this. Those are the primary ones that are decomposers. Really important part of all the food chains. Without these things, nothing would ever break down. Right? Did you ever wonder why like a dead rotting animal smells so bad? It's actually not the animal's meat or whatever that's smelling so much as the bacteria and the fungi that are feeding on it. They excrete waste. And so that horrible putrid smell that you smell, if you go by one on the side of the highway, is the smell of basically the excretion of things like fungus and bacteria that are feeding on it. So you're trained evolutionarily to dislike that smell. Like, we don't have to teach a baby to think that that's gross. It doesn't smell good to any of us, right? And the reason is, if you ate that, it would make you really sick, right? So automatically, you don't like that. And for some of the similar reasons to why you like sweet stuff. You like sweet stuff because we're, through evolution, basically trained to want things that have a lot of calories. And sweet stuff has loads of calories. It's hard to find sweet stuff in nature. You've got berries, things like apples, things like that. Now that we have refined sugar, it's really easy to get a hold of. And that's why we like it so much. It's loaded with energy. Okay, we're going to talk food chains next. Welcome to the bottom. We're not always the top of the food chain. But when we talk about top and bottom of the food chain, the things at the top are eating the things near the bottom, right? Or further down the food chain. So that's what the joke is here. So let's talk about food chains. A food chain is a very simple construct. It basically starts with a producer, and then it goes through the consumers that flow through that system. So we start with the producer over here, and the producer in this picture is, of course, the flour, right? And then we move over to the primary consumer. Note that I didn't say primary producer because there's just producers. There's not secondary producers. So now we have primary, secondary, and tertiary consumers. So we're going up the food chain. The primary consumer is the caterpillar that's eating right off of the producer. The secondary consumer is the frog that's eating the caterpillar. See that? Now the tertiary and above would be like the snake and then the owl, right? So as we go further up the food chain, that's how it looks. And those are the words we're going to use to describe it. Note one thing. This is going to be important today. Which way do the arrows go? Note the way the arrows go. They don't point towards the producer. They point the other direction. What those arrows actually show is energy flow. So they're showing energy going from the flower to the caterpillar to the frog to the snake to the owl. If you draw them the other way around, to a biologist, it looks like, the snake's eating the owl and the frog's eating the snake and the caterpillar's eating the frog and the flower's eating the caterpillar. So draw them the right way today when we do our next activity. Okay, so those are the trophic levels. So food chains, however, don't exist in isolation. A food chain is a very, very simple thing. Usually, biologists will draw these things in terms of food webs. Now, here's a food web. Oh, it's a lot more crazy, isn't it? But it's really just a combination of a whole bunch of food chains all interwoven together. Because in nature, it's never as simple as this to this to this to this to this. We've got little side arrows and all sorts of stuff going on. So it's much more of a complex sort of thing. And we even have decomposers on here. Okay, so that adds an extra added twist to it. Let's take a look at the differences here. Can you see how that's different? We've got the food chain, which is just a simple singular chain of energy flow, and the food web, which is a much more complex sort of thing. Okay. That's how you tell the difference there. And I think there's a question on your quiz about that. Okay. Yep, network of food chains, single sequence of feeding relationships. Can somebody describe for me a food chain that would include both a mountain lion and a shrub? What would be a food chain that includes both? Here's a shrub. Here's a mountain lion. What would we do? What do you got? Excellent. So shrub to mouse to mountain lion. Or we could go shrub to deer to mountain lion, right? You might see a question like this on your test, actually. It's pretty easy, though. You just start with the producer and work your way up to whatever we're talking about. So there's loads of different food chains within that food web. Okay, I'm going to ask you some questions here just so you can see how this works, and you might see some of these on the test. At which level of the food web is the supply of energy the greatest? So if these are the levels here, like all the plants here, all this stuff here, the next step up here, okay, where do we have the most available energy? What do you think? You know? At the bottom, that's right. So these things, in many respects, have like 100% available energy. Like there's no limit, because it's just sunlight. So they can just take as much as they need or want. Right? As we go further up the food chain towards the top, there's less available energy. Let's look at the first order heterotrophs. They're labeled here. They're the second, up above the second line. First order heterotrophs, that's the rabbit, the mouse, the birds, the deer. What relationship do they have in common? Does anybody know what they are? What's another way to describe a first order heterotroph? A primary heterotroph. They are all consumers. Excellent. What type of consumers are they? You know? They're what? Careful. Carnivores eat meat, right? So these are herbivores. Yep. So they're eating herbs. They're herbivores. Everything up here is a plant eater. Okay. So that's another way to describe a first order heterotroph. You'll see that on the little activity we're going to do today. They're all herbivores. What about the second order heterotrophs? So that was the first order. Up here at the top, the hawk, the mountain lion, the snake. Well, those, of course, can also be described as carnivores. So if you're a second order heterotroph, you eat meat, you eat carnage. If you're a first order, you eat plants, you're an herbivore. So see how the words are really similar? We can say the same thing with a different word. And why do we call plants autotrophs? What are they doing? Yep, they're producers. They're making their own food with photosynthesis. Okay, producers. Yep, the questions go right along with this on your quiz if you're following along on your quiz. Okay. Now let's do a hypothetical here, and I might ask you a question like this on the test. What might happen if we destroyed the mouse population? So let's say some disease wipes out all of the mice. They go extinct from the environment. Who's going to be the first organisms to be affected by that? What do you think? The mountain lions, right? Mountain lions are going to be hit. Anything else? I heard the hawk. The snake, yep. So everything above it that feeds on it is going to be most affected. Now, we might have said shrubs, because shrubs, maybe they'll grow more if there's less things feeding on them. But really what we're talking about is what's going to happen to these things up here at the top that feed off the mice. So looking at this, at least some of these creatures have some other means of food. Like the mountain lion can eat rabbits, mice, or deer. So it's probably maybe in better shape than, say, the hawk that really only eats birds and mice. Now it's only got one food source. So we can see what will happen to the food chains if we knock out a piece of the food web. Let's talk energy, numbers, and biomass. These are pyramids, and you'll see these. We mentioned one the other day. We have a pyramid of numbers, a pyramid of energy, and a pyramid of biomass. Notice for every single one of these, where are the producers? They're always on the bottom, right? And the highest level consumers are always on the top. Okay, so that's what we're talking about in every single one of these situations. But the reason they're there is kind of different. So this is going to show us mass and energy distributions in an ecosystem. So think about this one. What's the source of energy for every single one of these? The ultimate source. Yeah. The producers are, but where's their energy? It's the sun. It's this big thing right here, this ball of nuclear fusion that's going on up in the sky, right? It is the ultimate source of all energy. So if you stop for a moment, the energy that's coursing through your body, that's allowing you to move around, me to talk, us to do anything, all comes from the sun. Think about that for a second. You think your energy comes from your food, and it does, but if all your food traces right back to the sun, every bit of energy that's in my body and in your bodies came from the sun. We are all basically solar energy packets. We take this energy from other things and we move around and do stuff with it. Okay. Looking at the base of the pyramid of energy, of course it's producers, right? If we look at this pyramid of energy, you'll notice here, and this is a statement, you might want to jot down this 10%, okay? It's called the rule of 10%. As you go up from one level to the next, there's only 10% of energy available to each next level thing. So think about this here. If we've got producers, which virtually have 100% available to them, as much as they want, the next step up, herbivores that are eating the plants only get 10% of the energy from the plants that they consume. Right? They consume these plants, but they only get 10%. The carnivores that eat the herbivores only get 10% of the energy from the organisms they're eating. If we go up another one, the top level carnivores, they only get 10% of the carnivores beneath them that they're eating. Okay? The reason for this is because you don't actually digest all of the energy that's there. So let's say that you eat, I don't know, a cow. Okay, you eat a hamburger. You don't actually digest all of it. Some of it's just going out as waste. You don't get to break down every molecule in there, right? An awful lot of it gets lost as heat. So as you do the chemical processes, the metabolism in your body, you give off heat. So do all organisms. And so you waste a lot to the environment as heat. And when you add it all up, we only get about 10% from what we eat. So this is actually a fantastic description of why it's better to eat lower on the food chain. So if you're a vegetarian and you're like, I've been a vegetarian and this is awesome, here's a good reason to actually be a vegetarian. Because if you're eating down here at the producers or even the herbivore level, lower on the pyramid of energy, you get more energy from your food, which means you need less food to get the same amount of energy as something that's up higher on the pyramid. Isn't that interesting? Now, humans are essentially, we have evolved to be omnivores. We should be eating all like meat and plants, right? Both together. But this is a really good argument for being a vegetarian right here. You do need less energy. We could feed the whole world easily if everybody became a vegetarian. I'm not ready to give up my hamburgers though. Probably not bacon either. I was talking to a friend of mine who's a vegetarian the other night, and I was like, what does bacon do for you? Do you smell bacon and just lose your mind? And he was like, no. It's like, it doesn't smell good at all. It smells terrible. I thought, oh my gosh, like bacon, it's like the quintessential, like, oh, I'm so hungry if I smell bacon. Right? And what do you guys think? Could you live without bacon? It's pretty important to me. I don't know. So, we lose energy from one trophic level to the next. And so if we look at the pyramid of numbers, this is the number of creatures that are in each group. So if we took an ecosystem, let's say there's 1,500 grass plants there. There's obviously going to be more than that. It'd be a pretty small ecosystem, wouldn't it? Grasshoppers, compared to this number, there's only 200 grasshoppers, only 90 robins, there's only one hawk. So as you go up the pyramid, there can be less number of creatures. Just because there's less energy available. Do you get it? So at the top, there's less. Now, humans have kind of messed this whole system up, right? We are really up here towards the top in most ecosystems, but our population is humongous, so we're kind of like an inverted pyramid in a way. Right? The pyramid of biomass. I'm sorry, I put this in here. The higher levels of number, higher levels in the numbers pyramid have less organisms, right? There's less energy available. Okay. The biomass, what it shows is the amount of dry weight. So it's kind of gross, but what if we took all the grass and dried it out? How much would its mass be? What if we took all the herbivores and dried them out, like desiccated the bunnies and the cows and the birds and whatnot, and then weighed them, got their mass? How much would we have? And it perfectly reflects the other pyramids. The higher you go up, the less mass there is. So every one of these pyramids is showing the same thing. The higher up the pyramid you are, the less energy is available to you, and the smaller your population is. In nature, this is how it works out. Okay. Come on. All right, so you should have been able to answer all the questions on your quiz. Did anybody have a question they couldn't figure out? Okay, once your quiz is done, go ahead and submit that. The next activity we're going to work on is about food chains.